Introduction. In this experiment, my group will be working with 3 sets of sweets. Our goal is to know how often each flavor can pick after making 30 random selections. The key things to remember is that the 3 flavors will be at different frequency, so some might show up more often than others. Next, we can learn how to use probability in everyday situation. We could also gain a better understanding of probability through its application to real life. For example, if we roll a dice, the most likely to outcome would be 1, 2, 3 until 6. Apart from that, probability is a mathematical term that refers to the likelihood of an event occurring. It is the ability to comprehend and predict an outcome. We usually use probability to understand our surrounding by determining what is and is not likely to occur. The experiment of picking up a sweet was part of this project. We can conclude from this experiment that the outcome for the probability of picking up a sweet is either physicola, dynamite juice, or hard sense. Furthermore, the probability of an event can be calculated using the probability formula by dividing the favorable number of outcomes by the total of possible outcomes. This experiment requires a total of 30 sweets and the experiment is with replacement. Last but not least, we must close their eyes while selecting a sweet.
These are the objectives for our experiment. First, to access and record the frequency of each sweet flavor. Second, to calculate and compare experimental and theoretical probabilities of selecting sweets for different flavors when picked at random. Third, to develop critical thinking and analytical skills by interpreting probability data.
I will explain about methodology. We were given an experiment which is picking up a sweet for our group project. In this experiment, we need to randomly pick up a sweet for 30 trials. First step, we must prepare 3 different flavors of sweets. Make sure that each flavor is different in quantity. The total must be 30. Second step, we prepared 14 dynamite juice, 10 fizzy colas, and 6 Watson's lemon. Then, put them all on the table. Next, to ensure that the flavors are evenly distributed, thoroughly mix them all. Then, one of our group members will close their eyes to ensure random selection. The picker will then pick up a sweet from the top of the table, and the others will record the result obtained. After recording, the sweet should be placed back on the table for the next pick. And the last step is repeat step 3 until 6 for 30 times.
Question A. Observe and record the frequency of each flavor for the sweets. Since we are using of 30 picked sweet, the outcome, total flavors, dynamite juice at 14, fizzy cola 10, and Hudson 6. Our frequency for dynamite juice 20, fizzy cola 10, and Hudson 8. Next, question B. What is the experimental probability of obtaining each of the flavor? The formula from this question, experimental probability equal number of time event happen over total number of trials. Flavor, dynamite juice, the experimental probability is 20 over 30. Fuzzy cola, 10 over 30. And hard science, 8 over 30. Next, question C. What is the theoretical probability of obtaining each of the flavor? The outcome from this experiment, flavor dynamic juice, the theoretical probability is 14 over 30. fuzzy cola 1/3 and hard science 6/30.
Next, question D. What is the difference between experimental probability of obtaining dynamic juice flavors and the theoretical probability of obtaining dynamic juice flavors? Right answer as a percent, round to the nearest whole percentage. So for this question, we need to use formula experimental probability minus theoretical probability. And as we calculated before, for dynamic juice flavors, the experimental probability we get 12/30 and theoretical probability we get 14/30. After that, we need to minus both of that and we will get negative 1/5. Next, we need to multiply the answer with 100 because the question wants the answer in percentage. Lastly, we will get negative 0.07%. Question E. What is the difference between experimental probability of obtaining physical flavors and the theoretical probability of obtaining physical flavors? Right answer as a percent, round to the nearest whole percentage. Same like before, we need to use the same formula, which is experimental probability minus theoretical probability. For physical flavors, both of the experimental and theoretical probability that we calculated before is actually similar, which is 1/3. And we need to minus both of that. So it will be 1/3 minus 1/3 equal to 0. So the answer will be 0%.
So for the question F, what is the difference between experimental probability of obtaining Hudson-Simon's flavor and the theoretical probability of obtaining Hudson-Simon's flavor? Right answer as a percent rounded to the nearest whole percentage. So for this question, the formula that we can use is experimental probability minus theoretical probability. So the experimental probability of Hudson's lemon is 8/30. While theoretical probability of Hudson's lemons is 6/30. So 8/30 minus 6/30 we can get 2/30, and then multiply by 100% is equal to 6.67%, and then it will equal to 7%. Question G. What is the experimental probability the selected sweets are not dynamite juice? So let A is equal to dynamite juice, PA is equal to experimental probability of dynamite juice, PA prime is equal to 1 minus PA, 1 minus 12/30, so we can get 3/5.
Now we will move to additional questions where Siti have a big tube of 400 candies. There are 80 red candies, 60 yellow candies, 40 green candies, 120 purple candies, and the rest are orange candies. If Siti randomly pick one candy from the tube, what is the probability that orange candy is selected? Firstly, I write back all the information given. Total candies equal to 400, red candy equal to 80, yellow candy equal to 60, green candy equal to 40, purple candy equal to 120. To find the number of orange candies, we need to subtract the number of other candies, that is 80 plus 60 plus 40 plus 120 from the total number of candies, which is 140, and then we will get the total of orange candies, that is equal to 100. Now the probability of picking an orange candy is calculated by dividing the number of orange candies by the total number of candies, which is equal to 100 divided by 400, and it will equal to 0.25 or 25%. Therefore, the probability of selecting an orange candy is equal to 0.25 or 25%. Let's move to the second questions for additional questions. If Siti randomly pick one candy from the tube, find the probability that red and yellow candies will not be picked. First, we need to sum up the total of red and yellow candies, that is given by 80 plus 60, and it will equal to 140 candies. The formula for probability of not selecting red or yellow candies is equal to 1 minus probability of red or yellow The probability of picking a red or yellow candy is equal to 140 divided by 400, and it will equal to 0.35 or 35%. To find the probability of not picking a red or yellow candy, we subtract the value from 1 and we will get 0.65 or 65%. Therefore, the probability that red and yellow candies will not be selected is 0.35 or 65%. Moving on to questions 3 Roman, if Siti were to pick 60 candies from the tube, how many orange candies would she expect to pick? To calculate the expected number of orange candies when 60 candies are picked, we use the probability of picking an orange candy and multiply it by the number of candies selected. It will be 0.25 multiplied by 60 and it will equal to 15 candies. Therefore, Siti is expected to pick 15 orange candies. Let's move on to questions 4 Roman. 100 blue candies were added to the tube. Find the probability that Siti will pick a blue candy from one random selection. First, we need to find new total number of candies because it said 100 candies were added. So it will be 400 plus 100 and it will equal to 500 candies. The probability of picking a blue candy is calculated as the ratio of the number of blue candies to the new total number of candies. It will be 100 divided by 500 and simplify it. We will get 0.2 or 20%. Therefore, the probability of selecting a blue candies is equal to 0.2 or 20%. In conclusions, this project gave us a better understanding of how probability works in real-life situations. We learned that theoretical probability is what we predict based on mathematical reasoning and calculations, while experimental probabilities relies on actual experiments and observed outcomes. Through our study, we found that during experimental trials, the chances of picking specific candy flavor varied with each trial. Additionally, we explored the complement rule by calculating the probability of not picking certain flavor, which helped us to see how probability can also account for events that don't happen directly.